Question 7. Find the size of the angle A degrees that the line joining the points A, 0, minus 1, and B, 3 root 3, 2, makes with the positive direction of the x-axis. And we also have a diagram that accompanies this question. Here we should be thinking of m equals tan theta, where theta is the angle made with the positive direction of the x-axis, and in this case m is equal to tan of a degrees, since the angle that we're looking at is a degrees, and that is equal to m the gradient. We can find m the gradient since that we have 2 points that lie on the straight line, so it's y2 minus y1 over x2 minus x1, 2, and we're subtracting minus 1 over 3 root 3 minus 0. So that gives us 3 over 3 root 3, and we can simplify through to 1 over root 3. So we know that tan of a degrees is equal to 1 over root 3. The knowledge of exact values should tell us a degrees is 30 degrees, and that's the solution for question 7. Question 8. Functions f and g are defined on the set of real numbers by f of x equals x minus 1 and g of x equals x squared. Part A, find formulae for number 1, f of g of x, and number 2, g of f of x. If we first of all investigate f of g of x, f of g of x, since g of x equals x squared, that is f of x squared. Now the function f of x equals x minus 1. For f of x squared, wherever we see x, we will replace it with x squared. So instead of x, x squared, and we still need to subtract 1. So f of g of x is equal to x squared minus 1. Next, g of f of x, and we can rewrite that as g of, well, f of x is equal to x minus 1, so that will be g of x minus 1. G of x equals x squared. Wherever we see x, we'll substitute in x minus 1, so instead of x squared, it will be x minus 1 all squared. And that is a formula for g of f of x, x minus 1 all squared. Part B, the function h is defined by h of x equals f of g of x plus g of f of x. Show that h of x equals 2x squared minus 2x, and sketch the graph of h. H of x equals f of g of x plus g of f of x. So f of g of x, that's equal to x squared minus 1. And we're adding on g of f of x, and g of f of x, remember, is x minus 1 all squared. So let's expand out and simplify to see if we can get 2x squared minus 2x. So x squared minus 1 plus, and if we expand out x minus 1 all squared, that will give us x squared minus 2x plus 1. You can see that the plus 1 and the minus 1 will cancel out. So we've got x squared plus x squared, that's 2x squared, and we have a minus 2x, and indeed we've proven that we can get the function simplified to 2x squared minus 2x. For sketching 2x squared minus 2x, we've looked at doing so by making up a table of values. So if we look at x between the interval of minus 3 and 3, substituting these x values into the function will give us the following values: 24, 12, 4, 0, 0, 4 and 12, and that was done simply by substituting the x values into the function. So for example, for minus 3, that would be minus 3 squared, which is 9. 9 times 2 is 18, and we would be subtracting 2 multiplied by minus 3, which would be 6. 18 plus 6 would give us 24. And if we plot those points, we can see that the curve will look something like that. Question 9. The diagram shows the graph of y equals g of x. Part A. Sketch the graph of y equals minus g of x. Sketching the curve of y equals minus g of x involves reflecting the curve across the x axis. Now that means that the x coordinates remain the same. A is still A, 0 is still 0, B is still B, but we must invert the y coordinates. So minus 2 becomes 2, 1 becomes minus 1, and 3 becomes minus 3, and reflecting in the x axis gives us minus g of x. Part B. On the same diagram, sketch the graph of y equals 3 minus g of x. 3 minus g of x we can think of as minus g of x plus 3. That perhaps makes it a little bit more simple to think about how we approach drawing this curve. We already have the curve for minus g of x. So for minus g of x plus 3, it's simply going to be a vertical shift upwards by 3 units. So that will be our curve for minus g of x plus 3. Remember, we must also annotate the curve and show where our new points lie and what they are. So A2, a vertical shift upwards by 3 units, means that we're going to be moving up the y coordinate, and that will be A5. 0 minus 1 becomes 0, 2, and b minus 3 becomes b0. Remember, to get all of your marks in these questions, you must, as well as drawing the new curve, you must annotate and show the new positions of the points. And that is the solution for question 9.